This video is going to show you how to calculate an adjusted baseline using a model created with heating degree days and cooling degree days. So the first thing I want to go over with this is our list of temperature data. So here we have a list of temperature data for Wilmington, Delaware, but really it could be from anywhere. And we have the time and the date, and the other big things are we have the temperatures in Fahrenheit here, and then we have the hours since last measurement, which I'll show how to calculate it, and the heating degree days and cooling degree days. So everything up to column G is given, is from a database, temperature database. Temperature in Fahrenheit is just calculated from the temperature in Celsius using the 9/5 times Celsius plus 32 equals Fahrenheit. And then the hours since last measurement, what Excel does with that is you can just take two dates, subtract them, and if you multiply by 24, you get the hours since the last measurement. So you can see most are 1 hour, but some are 3 or 2, and if we look at the very end, some are in half-hour increments. So if you have hourly data, this step is not important because you'll know it just be 1 hour. But if you don't have hourly data, that step's important. Then to calculate the heating degree days, what you do is you have to take into account a couple different things. So first off, you have to know your base temperature. So if the outside temperature is less than your base temperature, then you should have heating degree days. If the outside temperature is not less than your base temperature, then heating degree days should be 0. So that's what this if statement takes into account. It says if the base temperature is greater than the outside temperature, then calculate a formula. If not, set the heating degree days to 0. So the formula is similar is what we've learned, which is the base temperature minus the temperature in Fahrenheit, the outside temperature, times the hours since the last measurement, divided by 24. And that's how you get heating degree days. Cooling degree days is similar, except the if statement's flipped because you don't want to have cooling degree days if your base temperature is greater than your outside temperature. So we'll learn about adjusted baseline in the next part of the video. So now that we've covered how to calculate heating degree days, we're going to go back to our adjusted baseline sheet. So one goal of an adjusted baseline is to adjust the, if you have a very hot or cold summer, say, is to adjust the electricity or energy use via a model. So what we're going to do is, first off though, is we have our billing dates. So with our billing dates, we want to calculate the heating degree days and cooling degree days that exist between those billing dates. So for example, for this cell that I clicked on here, B2, we want to calculate the heating degree days that occur between December 1st, 2009 and January 1st, 2010. So what we're going to use is a formula called SUMIFS for this. So if we go ahead and we type in SUMIFS, we're going to go ahead and do that. And what SUMIFS does is it sums given certain criterias. So we can use more than one criteria if we want, which is what we're going to do. So the sum range, in this case, we're going to do the heating degree days. So the full range of all the heating degree days in our temperature data. So we click the first cell of our range. If we hold shift and click the last cell, it selects all of those. The criteria range is going to be the dates of our temperature data. So again, click the last cell, scroll all the way up, hold shift, click the first cell, gives us that whole range. Then our first criteria is we want it to be greater than or equal to, so we want the date to be greater than or equal to, and we're going to select cell A2. So we want the date to be greater than or equal to December 1st, 2009. Now notice the sort of weird format I put it in. You need to put the greater than or equal to in quotes, then you have to put an ampersand, and then you have to put A2. So it's a little bit strange, but as long as you follow that, you should be good to go. And the way to check yourself too is to see whether you get something over here. If you get an error message or something over here, you'll know you've put a quote in the wrong place or something like that. So that's our first criteria. Our second criteria is going to be very, very similar, but the big difference is going to be that our criteria is going to be less than or equal to this date. So what we're going to do is just use this temperature as our criteria range. So that's, remember, that's from the temperature sheet, but this is the date. And then our second criteria is going to be the same as our first criteria, except for it's going to be less than. And it's going to be cell A3. So now what we basically have is that we're going to sum the heating degree days if our date is greater than December 1st and our date is less than January 1st. So that's exactly what we want for this cell. But we're going to also drag this cell down. And we want some things to change. We want the A2s and the A3s to change when we drag this formula down. But we don't want our ranges to change. So what we're going to go through is we're going to make these ranges absolute references. And once we do that, we can click OK. Now what we have is our heating degree days and cooling degree days, or I'm sorry, just the heating degree days for all the billing periods for all 3 years of what we're going to do for this adjusted baseline sheet. So next we'll go over how to calculate a 3-parameter model. So now that we have the heating degree days, what we want to do is first just plot the heating degree days versus the natural gas use, because that's going to be, and we're going to do the first year, because that's going to be how we build our model. So if we select the heating degree days cells for the first 12 months, and then hit Control to select the natural gas, and actually let's select the headers too, so that way we get a nice little looking plot. If we do that, and then we're going to insert a scatter plot. So it's important to do a scatter plot, not a line plot here, so that way even if things are out of order, they show up on the right axes. So here's our scatter plot, and we can see it sort of makes sense as heating degree days increase. So heating degree days are on the x-axis. As heating degree days increase, the amount of natural gas used increases, and that makes sense. That should happen especially if the building is using natural gas for heating. So if the building was using natural gas for only cooking or something, then this wouldn't be the case. So then the other thing we can do to build our model is we can add a trend line. So that's really going to be the linear modeling piece of it. So we're going to display the equation on the chart and display the r-squared value. Remember, r-squared, if it's 1, it's a perfect fit, and if it's 0, there's pretty much no fit at all. So let's get close. So we can see that our r-squared is relatively close to 1, and this is the equation of the line. So we want Excel to do all of these calculations automatically for us. So we could just type this in a cell, the 4.8216 and the 95.72 in a cell to have Excel do this for us. But it's not necessarily the best way we want to do. So let me show you the best way to do this. So what we can do is we can use the linest function to calculate linear fits for things. So let's go ahead and insert, and I'm sorry, in formulas and insert function, and we're going to go linest. So that just means linear estimation. And if we hit go, so now we can choose the known y's and the known x's. So let's go ahead to known y's. So the y's are the natural gas used, and we're going to do the first 12 months. And the x's are going to be the heating degree days, so the first 12 months of the heating degree days. So, and then the const is if we want to have B calculated or not. So it's either, if we make this false, B is set to 0. And we don't want B to be set to 0. We want a value for B because we could see that in our graph. So we want that to be true. And then what stats is that it's going to return, if we make this true, we can return things like the r-squared value. And if we make it false, we can return m and b. So for this case, since we're returning m or b, we're going to make this 0. So if we hit OK with this, what this gives us is the 4.812. And this isn't exactly what we want, because see how this is in the form E equals C plus B1 times degree days? So we want the M to be returned. So what we have to do is we have to put, and we can see when I'm typing in the formula, we have to put the index function. And so what happens is that when we do linest, it returns a variety of values. So the first value is not the one we want. So let's see if it's the second value that we want. So now we can see the second value is the thing that we want, the 95.72. And then what we're going to do is we're going to copy and paste that formula. So I hit Control C to copy and Control V to paste. And if we select the first thing, then we get the 4.82 in the right cell that we want. So again, we just put the 1 in here for in the index function. So then with the r squared, it's a little bit different. We can again paste because we're going to be using lots of the same values. But we want to put a 1 in here. Because again, we're going to this is returning additional regression statistics. So when we put 1, we're making it true. And then the r squared value is the third value, I believe. Yes, so there we go. So the third value is the r squared value. So as you can see, we have all of the things that we had on our graph now in usable form. The other thing you want to notice is that if we change our base temperature, that our r squared could go up or down. So 44 makes it go a little bit up, and let's say 20. So that makes it go down a lot. And we can also see that that r squared value is going to change our graph, because basically what it's doing is it's changing our base temperature is changing the heating degree days. So if we put it back up to 50, then that's a pretty darn good fit. So so we can play around with that to get even better and better fits. If we see that our r squared value is very low, we can play with the base temperature. So now that we have our model, so we have all our model parameters over here, what we're going to do is calculate our natural gas adjusted baseline. So here what we're going to do, instead of using the values that are from the utility bills, which are these, we're going to use our model and the heating degree days to calculate what we expect. So let's go ahead and go ahead and do equals here, and we're going to use this formula. E is what we're looking for, the natural gas energy use. So it's going to be C plus B1 times heating degree days. So that's our formula. So the other thing too is we want the B14 to change as heating degree days changes, but L3 and L4 are going to be constant. So again, we're going to make those absolute references. Okay, so then we hit enter, and that's the adjusted baseline use. So let's fill that into the bottom. And we'll make it a little more pretty just so we can analyze this a little bit. So what you can see is the general trend may be followed with this natural gas adjusted baseline. You can see in the summertime we definitely have much less natural gas use. And so when we do this, the adjusted baseline, it gives us what we would expect given changes in heating degree days or changes in weather. So from here, you can do things like calculate the percent difference of the natural gas actually used compared to the adjusted baseline, and the savings and other statistics. And it'll give you an idea as to if your building's performing well given changes in weather or performing not as well or not as efficiently.